In this video, we're going to be solving some more complicated multi-step linear equations. Let's remind ourselves of the steps to solving these equations. First up, you're going to want to simplify and combine any like terms that are on the same side of the equal sign. Remember, you don't have to do the opposite if they're already on the same side together. You're just going to be able to put them together. This first step can be multiple layers of steps and can take us a little bit of work on some of these harder equations. Once you've got everything simplified and combined, then we're going to use reverse order of operations to move things from one side of the equal sign to the other. So in step 2, we're going to try to get the variable or anything with a variable on one side of the equal sign and all the constants, the things without variables, on the other side. We're going to do that by adding and subtracting things from one side over to the other. And then last, we're going to get the variable by itself by multiplying and dividing to remove that coefficient off of the variable. Let's try example 1. First up, let's make sure we understand what are we talking about when we say on the same side. That equal sign is the divider that says this is on one side and this 2x plus 11 is on the other side. So things that are on the same side that are like terms, we're going to try and simplify and combine. We have to follow order of operations. So order of operations says we have to do what's in the grouping symbols first. But when I go to do that, I see it's 2x plus 5, and those aren't like terms, so I cannot put them together. We can get rid of those grouping symbols, though, by the distributive property. When there is no number in front of that parenthesis like that, we know there's really a 1 sitting here. And in fact, in our case, it's a -1. So we are going to distribute that -1 to everybody in that group. Now this little 4 out here is uninvolved in that process. He's just going to have to hang out and wait his turn. But let's distribute the -1. -1 times 2x is -2x or -2x. And -1 times a +5 is going to be -5. That got rid of those grouping symbols. Over here, I still have the 2x plus 11. There is still a little bit more to be done in step 1. We've got some like terms over here that we can put together. I have this 4 and this -5 that are like terms, and they are on the same side, which means we can put them together. 4 and -5, or 4 minus 5, is -1. Now that -2x still just hanging out. Everything over here still just hanging out. At this point, step 1 is done. We have put any and all like terms that are on the same side together. Now it's time to start moving things around. We want to get all the variables on one side of the equal sign. There's a couple ways you could do this. We could move this guy over to this side. Or we could move this 2x over to this side. You can choose to move either one. It doesn't matter. I think I'm going to move this one here over to that side. Now he is a +2x. So to move him, I need to subtract 2x. And what you do to one side, you have to do to the other. 2 minus 2, or 2x minus 2x, is 0. So those are going to cancel out. On this side, I still have the -1 and some like terms that we can put together now. -2x minus 2x is -4x. And I still have my 11 on the other side. Now, because I chose to move my x's over here, that means I then have to take all the numbers, the things without x's, like this -1, and move it over here. If I had chosen differently up here, if I had moved this x over, then I would have to move the 11 over here. So your first choice doesn't matter, but it does make a difference when it comes down here on what you do next. Since my x is on the left, everybody without an x has to go to the right. So I'm going to add this 1 over to this side. Negative 1 plus 1 is 0, so they cancel. And I've got negative 4x equals 12. I'm going to rewrite that over here so we've got a little bit more room. Negative 4x equals 12. The last thing we need to do to get x by itself is move that negative 4. It is negative 4 times x. It's being multiplied. So to move the negative 4 off of the x, we do the opposite of that multiply, which is divide. Negative 4 divided by negative 4 is 1. So we have 1x, or just x. And 12 divided by negative 4 is negative 3. So x is equal to negative 3. Again, if you had extra time on a test and you weren't sure, you could put this back in and check it. So you're going to put in your negative 3 everywhere that you see an x. And just make sure you carefully follow order of operations to simplify this side, and carefully follow order of operations to simplify this side. And you should get a balanced equation where this number equals this number. Let's try example 2. We want to simplify things that are on the same side. So over here, we're going to try and put some of that together. And on this side, we're going to try and put some of that together. Because we have those grouping symbols, and inside the grouping symbols are not like terms, we're going to use distributive property to get rid of those grouping symbols. Negative 3 times 2x is negative 6x. Watch your signs here. A negative 3 times a negative 2 is a positive 6. On the other side, I've got some x's that are like terms, and we could put them together. Negative 7x plus x is negative 6x, and then I still have the plus 6. This looks suspicious. Let's go ahead and stick to the steps and see what happens. I'm going to move all of my variables to the left side. So I am going to add this 6x so that we'll cancel, but what you do to one, we have to do to the other. Negative 6x plus 6x cancels on both sides, and we end up with 6 equals 6. That is a true statement, which tells me that my answer is all real numbers. Remember, if we get down here and we get something that's a false statement, then we have no solution. But this one comes out to be a true statement, so we know all real answers are going to work. Anything you put in here for x, as long as you put the same thing in here and the same thing in here for x, this side is going to have the same value as that side. Let's try one more. This one has a lot going on. Remember, anything on the same side that can be put together, we should put together. We're going to try and simplify this as much as we can. So first up, I'm going to distribute that 2. I'm also going to be distributing over here a negative 1, and here a 4. So let's get rid of these grouping symbols and see what we're left with. So 2 times 7, that's 14. 2 and negative x is negative 2x. Watch your signs here. This is a negative that we're distributing. So negative 1 times x is negative x. Negative 1 times 1 is negative 1. On the other side, we're distributing a 4. This 2 is just kind of hanging out. I'm going to have to wait for a minute. But 4 times x is positive 4x. And 4 times negative 6 is negative 24. I still have some more simplifying I can do. On the left, I've got some x's I could put together. Negative 2x minus x is negative 3x. I also have some regular constants that we could put together. 14 minus 1 is positive 13. On the other side, I've got some constants we can put together. 2 and negative 24 is going to be negative 22. And then I also have my 4x. At this point, step 1 is done. It took us a while, but we got there. We have simplified everything that we can and combined all the like terms that we can that are on the same side. Now it's time to start moving things around across that equal sign. So we're going to try and get all of our x's on one side. I'm going to minus this 4x so that I can put all my x's over here on the left. 4x minus 4x will go away. And over here, I'm going to have negative 7x now. And my constants are just staying put. Since I put all my x's on the left, that means all of the constants, or my numbers, need to go to the right. So I need to move this 13 over here. Now it's a minus. I'm going to be left with negative 7x on the left and negative 22 minus 13, or negative 35 on the other side. Let's rewrite that over here so that we have some more room. Next up, we got to get that x by itself. I need to take that negative 7 and pull it off of that x. The way we detach those is by doing the opposite of what's happening to them now. Negative 7 is being multiplied with x, so the opposite of that is divide. Negative 7 divided by negative 7 is 1, so I have 1x. And negative 35 divided by negative 7 is a positive 5. So we know that x is equal to 5.